Am I audible? Hello, everyone.
Yes.
Okay. Hello, Mr. Dimbles. How are you?
Hello, Chandra. How are you? Good to see you, buddy.
Yeah, I'm good.
Awesome.
Okay. So, without wasting the time, just let's start the session. Okay. So, in the last class, as I know that in the last class, whatever we have done, what we done in the last class, decision tree, right?
Yeah, it's the interview.
Decision tree, and I think we have done with the project, which was car price prediction, right?
That's right.
Okay. Now, today we are starting random forest and ensemble techniques. Okay. So today we will learn first of all ensemble learning, then in ensemble learning we will start random forest. Okay. Now what is ensemble learning? So basically when we talk about ensemble learning, ensemble learning, the meaning of ensemble means the group of the people. Group of the people. Or basically we can say that this is based on the wisdom of the crowd. This concept is totally based on the wisdom of the. What do you mean by wisdom of the crowd? Do you know that?
Like opinion of the most.
Hmm, correct. See, we will understand with the very simple examples. Let's say examples. The first one is democratic system. See, basically in elections, many candidates stands, but the one who gets the maximum number of votes, which is the number of citizen trust, right, will win the election, right or not?
Right.
The candidate who is getting the maximum number of votes will win the win the election. And what is that? This is the trust of the citizens to that particular candidate. Okay. So this is what? This is the wisdom of the crowd, that they are going to trust them. They are going to trust that people, that it will do some better things for us. Okay. So this is what? This is the wisdom of the crowd. Second, we can take one more example of that, product review system. Product review system. Can you relate with this? So let's say when you go to buy a product, to check its authentication, whether the product is right or not, then you read its review, and then if the reviews are good, then you trust the product. Okay, and this results is depends on the majority, right? The the maximum majority, the majority is going to be trust to that, is trusting on that particular product. That means this is the authenticate product, that I can buy this product, right or not? So this is what? This is the wisdom of the crowd for that particular product. Okay, just like a democratic system, we choose uh, one candidate, and then we trust that candidate, and then we give number of maximum number of votes to win that, right or not? So this is what? Wisdom of the crowd. So similarly, ensemble learning will do the same in terms of machine learning part. That means exactly this, the means of that is what? Means actually the collections the collections of various algorithm technique algorithm or technique to solve the particular problem. Okay. uh, Particular problem, it could be complex problem or simple problem now, or we can say that in a single line we can say that, or collections of various base models. Now don't worry, what is base model and what is the collection of various data models, and the base model we will learn in depth of that. Okay, model. This is the single line for the ensemble learning. Okay, now we have to remember some points when it comes to ensemble technique. Points to remember in ensemble technique. The first one is always, let's say you are going to make a model, the prediction model or the recommendation model. So what is the simple procedure? The simple procedure is what? That let's say you have 100% of data. Okay, let's say you have 100% of data. So in 100% of data, what you will do? You will split into uh, into 80 and 20 ratio, right? This is the This is the simple process. Okay, we split our data into X and Y, and then we will split our data into training and testing part. But apart from this, we will also do one more extra, the process, that is what ensemble techniques means. You can split this data to the different base models. Like what? So that's why I'm writing always use different different base model. Base model means you can say that different algorithms. Okay.
Always what? What it's
Always use different base models. Base models means different algorithms. Okay. Instead of uh, taking one algorithm, you can take multiple algorithms and you can apply multiple algorithms on the same data set. Okay. Just see this. See, let's say you have a data. Now this is your data. This is your 100% data. So what you are doing here, you are creating base models. So let's say this is your model 1. This is your model 2. This is model 3. This is model 4. And for the base model, for the first model, what I'm taking here, I'm taking a decision tree. Okay. For the second, I'm taking linear regression. Okay. For the third model, I'm just taking KNN. Let's say I'm applying KNN here. And the fourth model, let's say I'm applying SVM here. Okay. So giving instead of applying one model, you will apply different base models. Okay. For the same data. This is your 100% data, and you are applying this 100% data to with same data, and these are the different models. Okay. So previously what we have done, 80-20, then we apply KNN. But now in this condition, what we have done, we split our data into four categories. So let's say 25%, then 25%, then 25%, and 25%. And each 25% goes to model 1, model 2, model 3, and model 4, just like this. You understand? Now this is the first condition. Take the same data and just apply with the different models. Now the second condition is use small models, or use same model. Use same model means same algorithm. Okay. Same algorithm, but different distribution, but different data distribution. Okay. Like what? This is your model. Basically, let's say you are applying KNN model. Okay. This is your model. Now you will pass 25% data, then 25% data, then again 25% data, and then again 25% data. Okay, this is your D1 for decision tree. This is your D2, this is your D3, and this is your D4. Now, what is these? D stands for decision trees. Why? Because in ensemble techniques, basically, uh, the bagging and the bagging and boosting techniques will work. So this is what? This is your bagging techniques. Bagging means you are bagging, you are collecting the data in the bags. Okay, these are the bags. These are the bags for the decision 1, decision tree 2, decision tree 3, decision tree 4. Okay, this
Sir?
is it. Yes.
What is KNN?
Oh, yeah, yeah, you fixed it. I thought,
KNN, K nearest neighbor. The
Sorry?
algorithm which we have, K nearest neighbor, the algorithm which we have done previously in the past class. I
Yeah,
think that
it's one,
was
yeah,
the
it's one of those models.
second or third model, I
Second
think.
one, the second one, yeah.
Yeah, second one.
The first one is a regression model.
Yeah, the first one was regression, and then the second one was KNN. Okay,
And
you have to revise it. Clear? But this is not for the KNN, but actually you are getting, I think you are getting the concept or not?
Yes.
so, yeah, I have a question. This
Yes,
D,
yes, sure.
let's say this one is decision tree. So we're gonna have four different types of decision trees. Is that what you mean? So first of all,
Yes.
we divide the data into 18 training, 80% train, and 20% test for KNN. And then we further split this data into four parts, 25% for decision tree one, 25% for decision tree two, 25% decision
So
tree. Is that what?
this process, yeah, actually this process is going to under in training process. Okay,
Okay.
while the training process, but we are not actually doing manually by ourselves. Okay, it will
Okay.
automatically do in the internally when we apply the algorithm. Okay, whatever we are learning here, these are the internal process of the algorithm. Okay, we are understanding how the algorithm works. So algorithm will work like that. The first condition, it will take the same data and it will take the different models. Okay, and but when it comes to different models, we have to pass the models like decision tree, the like linear regression, then KN, and then SVM. But when it comes to second number of condition, use same models, means we are picking a decision tree or let's say KNN. Then uh, then right after that, we are using different data distribution. Different data distribution means we split the data into four categories: the first decision tree, the second decision tree, the third decision tree, and the fourth decision tree. Means 25% of data. Let's say in decision one, let's say my accuracy is for 25% of data and applying KNN imputer for this type of data, and we are getting 80% of accuracy. Okay. For decision two, we are getting 85% of accuracy. For decision three, we are getting 75% of accuracy. And suddenly for decision 4, uh, we are getting 87% of accuracy. So this one is your best, right? The decision 4 distribution, data distribution is going to be best accuracy, right? So in this way, that algorithms works internally, how the data distribution is, and how we have to calculate the accuracy according to our data distribution. Okay, and all this process will going to be work in internally when we train the data. Okay, now basically we have a types of ensemble techniques. Okay, then we will categorize the voting technique and the bagging technique and the boosting and so many the techniques we have and so many algorithms according to the types of the ensemble. But this is the base thing, okay, how the ensemble techniques will do. But right after that, we have to apply the models. We have to apply the algorithms. Okay. Now,
So accuracy is like for after getting the 4 different accuracies, how do we decide like what's the decision we take?
automatically the higher accuracy will take the algorithm and it will provide in the form of accuracy. Okay.
Okay,
Okay. We don't have to decide it. Algorithm will going to be decided. Okay.
got it.
Now, types of ensemble. So basically, we have 4 types of ensemble. The first one is voting ensemble. The second one is bagging technique. Second one is bagging. Third one is boosting, boosting technique. And the fourth one is stacking. Fourth one is stacking. Now, basically, we are going to learn the bagging and the boosting. Okay, especially bagging. Why? Because we are going to learn random forest, and random forest is the algorithm of bagging technique. Okay, so we can say that bagging with random forest. Okay, this is the first. Now, basically, in boosting, we have these are the algorithms. Okay, basically, these are the algorithms. We have ADA boost, ADA boost. ADA boost means adaptive boosting. Second one is we have gradient boosting. Third one is XG boost. Okay, XG boost means extreme gradient boosting. Okay, basically this is the advanced version of the gradient boosting. XG boost means extreme gradient boosting. So let's say uh, you applied the random forest, you applied the decision tree, and still you are not getting any good response. Good response means still you are not getting uh, the right accuracy. Then you will apply the boosting technique. Boosting means to boost up your accuracy part. Okay, so then you will apply add a boost on top of that, and then you apply gradient boosting, and then you apply XG boost, whatever it will be fit for the model. You can just keep applying these algorithms on that particular model, and when you realize and when you feel that yeah, this is the good accuracy that we are going to expect from the model, that we can take the ADA boost or a gradient boosting or whatever you applied on that model. Okay, so this is for the boosting of the model. Okay, so as I can mention here, boosting the accuracy of the model. Okay, now what is stacking? Stacking means now what is voting? Basically, voting is just same as the wisdom of the crowd. Okay, voting just like a democratic system. Like mm, we distribute our data into like 25%. Okay, this is A, and similarly B and C and D. And let's say in voting techniques, algorithm is saying the prediction, let's say 5 years, and for 25%, let's say it is saying 6 years, and for C, let's say it is saying 8 years, and it is saying 3 years. So which one is going to be win? The 8 number, right? Why? Because algorithm is saying that 8 years is going for this data. So we combine the data and then we apply the same algorithm and it will give you the accuracy. But this is not, the mandatory part, because the voting technique will automatically comes under in random forest. So that's why random forest is very dynamic. Random forest is very, very, the extreme level of algorithm which will apply on the same, on the both of the regression problem and the classification problem. Now, what about the stacking? See, stacking is just like it's just like the voting techniques. Okay, it basically same as the voting ensemble voting ensemble, but one different is, but the difference is weightage of the vote. Weightage of the vote. Let's say uh, votes are, let's say, weight number 1, weight number 2, weight number 3, and weight number 4. Okay, so we have two kinds of weights. The first one is low weights and the other one is high weights. So whose weight is high? Low weight and high weights. And whose weight is high? That is going to be win. Okay, so let's say weight number 1 is low and weight number 2 is low, but initially automatically weight 3 is going to be high. Okay, and weight 4 is going to be high. That means combinedly with this W3 plus W4, W3 plus W4, let's say value of W3 is 2 and W4 value is 6. So 6 plus 2, 8, and 8 divided by 2 is 4. So 4 is your prediction. Okay, so how the stacking works look like this. Okay, this it is based on the voting techniques. So we will provide some so algorithm will apply the techniques on the data, and it will count the votings, and based on the code votings it will check which one is lower weightage and which one is higher weightage. and it will go for counting the number of votes. And if the number of vote is same, let's say 2 votes and 6 votes, but the weight is same, then it will take the average number. So 6 plus 2 upon how many numbers? Two numbers, W3 and W4. Then we will divide it, and we got 4. So 4 is your prediction. Okay. Now understand what exactly the random forest. This is for stacking, this is for boosting, and these are what? These are the algorithms of boosting techniques: ADA boost, gradient boosting, XG boost, and extreme gradient boosting. Okay, this is the name of the XG boost. Now, in our syllabus, basically random forest is very important, and also for the point of view of exam or interview. Okay, so random forest is very important. Now let's understand how the random forest is works and what is random forest. Did you understand what we have written here? Any query? If you have any query, please ask me. These are the types of ensemble.
What's the difference between bagging and boosting?
Okay, we are going to cover in random forest the bagging and the boosting.
Okay.
So in a single line, if I talk about bagging means data distribution, and boosting means boost up your performance. Okay. Random forest. Now, first of all, it is a supervised type of machine learning algorithm. It can be used for both classification and regression problem. Used for solving both regression, classification, and regression problems. Okay. And the third line is, it is based on the ensemble learning that we have recently discussed. It is based on the ensemble learning. Now, what is the meaning of ensemble learning? We have discussed right now. Recently, we have discussed combining multiple classifiers. Combining multiple classifier or regressors, okay, to solve a complex problem and to improve the to improve uh, performance of the model. Okay, now let's understand the random forest, the meaning of the random forest. See, forest. So basically, random means bagging. This is totally based on the bagging based technique. Okay, uh, don't worry. We will understand exactly what the meaning of bagging and the bootstraps and the aggregation also. Okay, so basically, it is bagging based technique. Now, what is bagging based technique? Basically, it works on the principle of bootstrap and aggregation. Okay, and this is what? This is the sampling method. Sampling of the data. Okay, sampling means a random selection of the data. Okay, and what is the meaning of forest? The meaning of forest is basically group of trees, right or not? Okay, so group of trees means it will work on the principle of group of trees. That means in this multiple decision trees are going to be trained. Okay, multiple decision trees. Are trained in this concept. Okay, so random selection of the data and the group of the trees. Group of the tree means multiple decision tree. So as I told you, see this part. So this is what always use different base models with different algorithms. So this is what exactly? This is the multiple decision trees. Okay, see these are the decision trees. These are the
Hello,
decision trees.
hello, Surrender.
Yes, Aniran.
Yeah, can we call group of trees the traders?
Sorry.
Can we call group of trees? Can we call them the
Group of
traders?
trees. Actually, group of trees means the decision trees. So recently we have done the decision tree concept. Okay.
Okay.
In the last class, we have already done with the decision tree. So how decision tree works? It is based on the if and else condition. It will work like that. See. Then again it will split into the yes and no. Then again it will split into the yes and no. So these are what? So
Okay.
like these decision trees, it will create so many decision trees. Okay. So
Yeah.
it will understand more internally the patterns, the hidden patterns or the trends. Okay.
All right. Thank you.
So group of trees means these are the models. And random is the bagging based technique. That means you are distributing your randomly selection of your data. Okay, randomly selecting your data and passing the data to the models. Okay, and these are the models. So combinedly, we can say that this is totally based on the principle of bagging and boosting techniques. And uh, the forest means random forest means the forest which inclined you to in the group of trees or the multiple decision trees. Okay, that is that's why it is very most powerful algorithm to give the good results or excellent accuracy and performance. Okay.
Yeah. Thank you.
Now, how it actually works? Let's understand this. How it works. Suppose you have a data set. Uh, we are talking about bagging. Okay. Suppose you have uh, data in which thousands rows we have, 1,000 rows. So you will work in two steps. Two steps. The first one is you make the base model. U means algorithm. Okay. Algorithm make the base models. Like we have a data and we are going to split in decision tree 1, decision tree 2, decision tree 3, decision tree 4. These are the base model basically.
This abbreviation looks same like data and decision tree.
Data and decision tree. No, decision tree is something different.
Yeah, but when you type the DT, it sound like a data.
No, actually, this is your data. Okay. This is your 100% data, and these are the base models. That's why I've written here. These are the
Okay.
models. Models means
Okay.
algorithm.
Algorithm. Okay. Got it.
Yeah, we're gonna divide the
Yeah.
data
Yes, yes.
into 4 equal parts.
Yes, yes, exactly.
Okay.
Okay. So these are the base models, or you can say that these are the small decision tree based models. Now we will give the data to every decision tree. Okay. Now I'm going to write a very simple steps. Let's say these are the decision trees. These are the decision trees. Now we will give the data the data to every base model or decision tree. Okay. But you never, but remember one thing, the third number note, you never give whole data. Why? Because this is the sampling technique. This is the bagging technique. But you never give whole data. Only sample data you provide. Okay. Now, how to give the sample data? This is the question. How to provide sample data. So actually, we have three methods. Okay, three methods to provide the sampling. The first one is row sampling, and the second one is column sampling, and the third one is the mix-up of row sampling and the column sampling. Okay, now understand what exactly row samplings works. So provide sample data by making sampling. Okay, so three ways to create sample. Now the first one is row sampling. Okay. So let's say you decide you give 400 rows to each tree. Okay, let's say, for example, in row sampling, uh, let's say you have a data, 1000 data you have. Okay, starting from 0, then 1, then 2, then 4, and goes up to 1000. These are the rows. Okay. Now, what you are doing, you are providing randomly, you are providing 400 rows. Let's say you have created four base model, four base models. Okay, so for how you will distribute this 1000 data to four base models, and in each model basically we have to pass 400 rows. Is it possible?
It would be 2.5, right?
2.5.
Because 400 into 2 will be 800 rows.
Yes.
Then half of the stacks for the third row.
See, that's why for this problem we have one more concept that is called with replacement and without replacement. So let's say uh, you have to pass 400 rows to each decision tree, each tree or model. Let's say model. Okay. For example, you have 1000 rows and you have to pass for, this is the model. Okay. Model number one, then model number two, then model number three, and then model number four. And you are providing 400 rows to the first model. Now, how many rows are remaining? Total 600 rows are remaining. And we need to split this 600 rows to the model 2. So, what is the chance to get the same number with the model 2? Let's say, let's say for the first model, it is taking randomly, it is taking 1 and then 2, 2, then suddenly it takes 20, 150, okay, and then 200, and like this you will provide 400 rows to the model 1. Then again, this is for model 1. Okay, this is for model 1. Now let's say for model 2 you are taking randomly the algorithm is taking 55 and then again 57, then 60, then suddenly it takes 2. But the problem is 2 is already present in the model 1, right or not? So it will check this and it will replace that number. It will replace that number with the another number which is not present in the model 1. So let's say 4 and then 6. Now suddenly right after 6 it is taking 55, but 55 is already present in my model 2 in the same model. So it will replace this 55 to the another number. Okay, so it is replacing with the, let's say, 62, and it will take the 62 number. So this is what, this is with the replacement. You are replacing this number, you are replacing 55 with 62. Okay, so this is what, with replacement. Clear?
So the procedure is to avoid repetition of the number,
Repetition,
whatever.
yes, to avoid the repetition of the numbers. Otherwise,
So
your model will be going to be is very worst, right? Why? Because the number of elements is repeating.
let's say in model 1, so we are going to have 400 rows, right?
Mhm.
Is that what you say, right? In model
Actually,
1?
actually, Mr. De Bliss, please just hold on. Actually, we did some mistake actually.
Yeah, because
Yes,
if we
because
divide for each model, if we say 400 times 4 model, it's gonna be 1,600, which is
yes.
beyond.
Yes. Actually, the number would be same for model 1 and model 2, but not be same for the same model.
Okay.
Okay. Let's say I got 2 here and I got 2 here. It will be fine,
Okay.
but
But different model. Okay. I think makes sense.
different model,
Exactly, makes sense.
not in the same model. Okay.
Okay.
Now we can distribute 1,000 rows to the 4 different models, and
Which
each
are
model gets
400 rows.
400 rows.
Okay. So
Clear?
the numbers could be repeated in different models, but because they are different models and then the results are not the same, right? Even if the numbers are the same, so the model performance or what the outcome is different.
Yes, exactly.
Okay. It makes
So,
sense.
so the model has to be number. Can we do A, B, C, D?
Model, yeah,
Those are
basically
rows. Uh-huh.
we didn't define any model. The the algorithm will decide how many models it has to be created. Okay. Let's say
Okay.
uh, you can also, I think you can skip this process and manually you can provide how many base models I need to put here. So basically we have a parameter that is called an estimator. So an estimator, let's say if you are putting an estimator is equals to 5, that means you are making 5 models. Okay, but by default it will take automatically how many, because random forest is very dynamic, it will automatically consider how many models it has to be take. Okay. Clear or not?
Yes, I think
If
we're
it
gonna continue.
if it is not, please tell me.
So
See,
the
by default,
repetition, sorry.
yes,
So repetitions in the same model will be replaced, but in different model it can repeat, right?
yes, it can be repeat. Okay. Take 1 minute time and just understand the concept. you are not getting the concept, please tell me. Or you have any query. Then we are going to understand the aggregation. Okay, clear? Can we continue?
Yes.
Yeah.
Okay. Now the second one is aggregation. So basically, aggregation will happen when we do the prediction. Okay. And bagging will happen while we are training the data set, while the training time, and aggregation for the prediction time. Okay. Now, how it works basically. So when your data is trained, when your bagging process is done, then we will move forward to the aggregation. Now, how it works. So in this, you will ask the question to each of the
What is the you will in this you will talk?
ask
Ask. Okay.
ask the question. Ask the question to each of the model. Okay.
Okay. Thank you.
Because it is already trained. Right? It is already trained and it is ready to prediction. Okay, it is ready for the prediction. So in prediction, it will ask the questions like what? And it will ask the question and the model gives you the answers. And number of frequent answer, number of frequent answers means the average answer, average value. Okay, or we can say the maximum answer will be the best output. will be the best output. For example, let's say out of 100 students, out of 100 students, when the algorithm is asked, when the model is asking the question, like how many students are going to be placed the cricket, so model says 20 play cricket, 20 students play cricket, 30 student like carom, playing like carom, and 50 students play tennis. Okay, so according to the majority, tennis is going to be win. Okay, so this is for classification. Okay, this is for classification. Now, when it comes to regression problem, in case of regression, in case of regression, let's say you got random answers, or numbers. Let's say 2, then 2.5, then 3.5, then 5. So it will make the mean of that numbers. Okay, so like 2, then 2.5, then plus 3.5, then 5, and we will divide it by 4. So 3.5, 4 to 6, 6, 6 to 8, 8 and 5, 13. 13 divided by 4, so 4, 3, 12, 2, 5. 3.25 is the prediction. Clear? This is for regression, and this is for classification. You understand? What is aggregation? Aggregation will only happens right after the training part, and bagging is happening under the training part. Okay, bagging means distribution of the data. Then right after the distribution of the data, it will train the data, and whatever the mathematics we have inside the random forest, it will do internally in that. Okay, then right after the training part, we will do aggregation, and aggregation in terms of classification, basically it will ask the question, and it will check the number of frequent answer or the average answer or the maximum answer will be the best output. Okay, the best output, or we can say that will be the classify number. So let's say 20 are going to be let's say cricket, and 30 are going to be play carom. Okay, and 50 are going to be play tennis. So 50 is the classified value. Okay, and
So,
what is the problem here? So let's say, okay, just 1 minute. Let's say you are asking how many students are like how many students are likes cricket, carom, tennis in 100 students. Okay, in a class, and you are classifying based on what? Based on the class, based on the height, based on the let's say based on the weight, height, okay, the standard, and whatever the parameters we are taking. Okay, so based on that parameters, we are classifying which student is playing, which student is likes uh, carom or cricket or the tennis. Okay, and this is for regression problem. So let's say we got two, let's say the any random value, let's say 5 or 7 or 6 or whatever we have. So it will collect all the numbers and it will take the mean of that. Then then the resultant number would be your prediction. Yes, tell me. Yes, Devlis, you are asking something?
Yeah, I got it. I think because I'm just trying to for the classification and in
Oh,
the
okay,
previous
okay.
in the previous models we talked about the binary classification in the case of logistic regression. So in this case, so the classes could be multiple, right? Multiple classification, right? Like you
Yeah,
mentioned.
multiple classification. Like we have
Okay.
three classification here. See, cricket,
Could be
carom, and
four, or
tennis.
it could be any number of classification.
Yes.
Okay, got it. Thank you.
Okay. Any question?
So how do we choose when to use which method, like classification or regression?
This is very simple. We have already seen a lot of data sets. If you have a continuous data, then you will choose regression. If you have a classified data, let's say if you have a two or three possible outputs, let's say yes and no, true and false. Okay, let's say cricket, carom, and tennis. Who is going to be play cricket, or who is going to be play cricket, carom, or tennis? So this is what this is the classified data, right or not?
Right.
So the numbers are if the numbers are in the unique format, if the numbers are in the continuous format, like 1, 2, 3, 4, 5. These are what? These are the regression problem. These are the regression. So in the last class, we done the car price prediction.
Mhm.
And what we have taken? Regression or classification?
Which one for this example?
For car price prediction. In the last class, we have done that question. I mean the project.
I think regression because we're talking about the selling price, right?
Yes, selling price is in the form of continuous data, right? Every
Yes,
value
data.
has the unique value.
Right.
Mhm.
Okay. So first you understand the difference between the classification and the regression. See, classification is simple. When you have in the output column, when you have only two possible or three possible categories in the output column, that means this is the classification problem. And if you have a multiple entries, if you have a continuous data in the output column, that means this is your regression type of problem. Clear?
Yes.
Okay. Now let's take a quick break here. Then right after that, we will take data set. I think in the last class I shared, we have already discussed on the penguins data set, right or not?
Which data set?
Penguins data set, penguins.
Yeah. I think we did that one.
Okay, so exactly same data we are going to take today for the random forest. Okay, then we will classify which species of the which is the particular species of the penguins of that. Okay, that was the classification. That was the classified data, right?
Right. Okay. Yeah. Type
Okay.
of species because we're talking about type of species, right?
Sorry.
Yeah, that was classification, I think.
Yeah, that was the classification. Okay, so based on the uh, length, and based on the whatever we, I don't know
Yeah, to
exactly what was that,
estimate the species, right?
length and the width, what was the species of the penguins, right?
That's right.
Yeah. Okay, we will discuss.
Sì, una classica va. Yeah.
Okay, everyone, back to the class.
Yes, sir.
Okay, so just create a new collab file. Okay, just connect the file. Just rename that file. So random forest classifier with penguins data. Okay, so first of all, just name that. But before that, let me show you. I think we have already discussed on that. Penguins dataset details. Penguins species classification model. Import the libraries. Import pandas as PD. Import numpy as np. Let's run this. So let me check it. Okay, see.
Is that from Kaggle?
Yeah, this is from the Kaggle. Actually, this data set is very common. You can take this data set from Kaggle also. You can take this data set from sklearn library also, and you can take this data from the Seaborn library. Okay, this is a very common data set for learning purpose. So see, basically based on the bill length and based on the bill length and the bill width, and based on the length of the flipper and width of the flipper, we will decide what is the species of the penguin. Okay, clear or not?
So it's gonna be classification, right?
Yeah, this is the classification. So first of all, load the data set. Load the penguins data set from the Seaborn library. Okay, so first of all, for load the data set, what you will write, df is equals to sns dot. Okay, first we have to import the Seaborn library also. Import Seaborn as SNS. Let's run this. So SNS dot load dataset, load underscore data set, and inside the parenthesis you just have to write penguins, the name of the data set, penguins. Okay, now just run it. Okay, now just check the df. So df
It's
See.
showing a value error.
Showing the value error.
Loading.
So
SNS.
SNS dot load underscore dataset. And right after the dataset, you have to put the parenthesis, and inside the parenthesis, you just have to pass the name of that particular dataset. Okay, so the name of the dataset is penguins, PENGUINS.
Okay. Got it. Thank you.
Got it? Okay. Now, these are the columns. Basically, we have a species column. So species is going to be your output or targeted column. Okay. Based on the island, based on the bill length, based on the bill depth. Okay. Bill depth, flipper length, and based on the body mass, and minimize this, and based on the gender, so male, female, female, and we have some none values also. Okay, so now without wasting our time, we have already discussed on the previous classes, and the previous classes this that. Now first handle the missing values. Handle the missing values. First we have to check the missing values, right? So df dot is null dot sum. Let's run this. So total how many missing values we have? Almost the highest number of missing values is in the sex column. Okay, so total 11 genders are missing. 2 from body mass, 2 from length, 2 from build length. So total how many missing values? 11 to 13, 13, 15, 17, and 19. So we have to remove 19 entries from the data set. Okay, so how will you remove that? Remove the non-values or missing values. So df dot drop na. So basically we have a function that is called drop na function. Drop na, and simply write in place is equals to true. True. Okay. So in this way you can permanently delete that values. Okay. Or I think you can do one thing. You can reserve the data frame, I mean the main data frame, and you can put these values in a new data frame. So let's say I'm taking data. Data is equals to df dot drop na, and just remove this parameter. I'll just run this. Now check data dot is null dot sum. See, we don't have any null values here, right? So print the actual shape of the data. Actual data shape. So df dot shape, and similarly print actual data set and data shape, and cleaned data shape. So we have a data.
So excuse me,
data
so
dot.
you
Yes,
you gave a new name to the data, right?
yes,
Previously we had
I-
df, and then after dropping missing values, and so the new name is data, right?
yes. The new name is data. Okay, so that's why I've
got it.
written clean data set.
Awesome, thank you.
See, previously we have 344 rows and 7 columns, but the clean data shape is 333, right? So we have successfully removed how many rows? Tell me. 11 or not?
Yes.
Okay, perfect. Now what we have to do is we have to encode the categorical feature, right? Why? Because see, these are the categorical features, the sex column, the island column, and the species column, right? So we have to encode it. Why? Because these are in the string categories, but we have to encode it in numerical column. So just mention here encode the categorical features into numerical values. Okay, let's run this now. First import the label encoder and the standard scalar. Import the required model and the method. So from sklearn dot, that was the part of the pre-processing. So import label encoder label. So instead of manually doing one hot encoding, we are using label encoder here. Okay, and standard scalar. Standard scalar for what? For making your data normalized, right or not?
Yeah, that's right.
Yes.
So
Yes,
we are
run
doing
this.
two. Okay.
Yes, please ask me.
Yeah, good. I think, yeah, so I got it. You're trying
Okay,
to first encode the categories of
categorical
levels of,
features.
yes, levels of categorical data, and then
Yes.
standardize them. Okay.
Yes, so we have a species column
That's right.
and then we have a sex column, okay, or the gender
Mhm.
column, and then we have one more column that is in the categorical. That is what? Island column, right?
That's right. Speech, island, um,
Island.
sex, 1, 2, 3. Okay.
Total 3 columns we have in the categorical feature.
Oh,
But before this, you can also check how many categories we have. So first of all, data dot columns.
mhm.
So check the value counts. So data and
Wow.
species, how many categories we have in the species. Okay, so then we will understand how many species we have. Okay,
Mhm.
so value counts. So total how many categories? three species we have: Adelie, Gentoo, and Chinstrap. Okay, so the maximum number of species we have Adelie, right or not?
So we're gonna do
Okay.
the same thing for islands and sets also, right?
Yes. To
For sets,
understand
we
how
don't have to
many.
do that one. Okay.
Yeah, I think
And
for sex column, I think we have only two categories,
for
the
island, we need to do that.
female and male, right? Now check for the island. Or you can check with the unique function. We have a unique function also.
So did you share the data? Is that the old data? The data file?
Actually, we import the data from the Seaborn library. See,
Seaborn library. Yeah, the penguin. Where is
yeah,
this
the
came from?
penguins data.
Where this came from? Did you send it to
It
message?
is came from the internally from the Seaborn library. We
Oh,
didn't
from
have
the
defined
Seaborn
any.
library?
We are just importing from the Seaborn library.
Oh, okay.
Okay.
So there is
So if
no
you
you didn't send
no,
it
there is no
share.
any
Okay.
external data. Obviously, you can take this data from the Kaggle platform, but what we have done here, we have load the data set from the Seaborn library. Okay, so
From the Seaborn
SNS,
library. Okay.
yeah, SNS dot load data set, and then we have defined the name of the data set, penguins. So you will
Oh, okay.
automatically get the data. Okay.
Okay, you mean you went to the Google and got there from there, right?
Yeah.
Okay.
And actually, we have a unique function. Unique function will give you the list of that unique values. So in island, we have three types of island: Toggerson, Biscope, and Dream Island.
Dream. Oh, okay.
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 Now we have to encode them.
Can you share also the file for the data collapse, the Google
Yes, sure.
collapse?
Yes. Give me a minute. Got the file?
Yes.
Is that meeting is recording or not? I don't know. Yes, it is recording.
I think yes, it is.
So wouldn't it be a good idea to share the file once we finish it? Oh, I think somebody's using it, sorry.
Yes.
Yeah, it's okay.
Okay. So let's say I have to create a object of that object of the label encoder. So what I'm writing here, label. Label is equals to label encoder. Put the parenthesis and just run this. Now, where I'm going to make changes in species column. So data. Okay, so data is my new data frame. Okay, Dimlis. Okay, Suli. And
Yeah,
rest of
absolutely. That's
okay.
where we removed missing values,
Missing
right?
values where we remove the missing values, and we have
Mhm.
already the actual data set also in DF column in data
That's
DF
right.
data frame. Okay,
Okay, got it.
so
Makes
in
sense.
this way you will never lose your actual data set.
Mhm.
Okay, now species. In a species you are going to make the change, and just put the label here. Label is your object of the label encoder. Okay, then dot, we have a fit and transform function, and in this you will define data and you will define the name of the column. So species. Okay, and this is what, this is your target or output column.
That's right.
Now, same for the island. So data, so instead of writing, let's copy this.
Mhm.
So instead of species, just make it island. Okay, and similarly here, island. And we have a sex column. And similarly, we have to update here, sex. Clear?
Yes, sir. So it doesn't put in a ranking order, right? It simply identifies levels of a categorical variable, right?
See, yeah, basically label encoder is separately meant for encoding the variables, encoding the values. Basically, it automatically converts your categorical into numerical. So it will start from 0, 1. Okay, so start from 0 and then 1 and then 2. Okay, it depends on the categories, how many categories we have. But it will only gives you in form of 0 and 1. Okay.
Out of these three, only the species column is the output column, right? The others are inputs.
Yeah, others are the inputs. Species is the output column. Why? Because based on the different input columns, I mean, based on the bill length, bill depth, and flipper length, flipper depth, and body mass index, and based on the sex, we are predicting that what is the species of that particular penguin. Okay. So the species column is your target column or output column.
Excuse me, Sunandra. So
Yes.
can you, because I think I understand this one. So what about if we want to apply one hot encoding? What's the difference between level encoding? So this one is for not ranking, for not order.
Actually, see, actually, we have how many categories? We have 3 categories, 1, 2, and
Right.
3, right?
That's right.
So that's
Yeah.
why we are taking label encoding. But if
Okay.
you have only 2 categories, then you will go for one hot encoding.
100. Okay. So if the levels are 2, one
Yes,
hot encoding is appropriate, and then if more than 2,
more than 2,
right,
then
if
the
it's more.
label encoding will be best.
Got it. Thank you.
Okay. Now just run this. Okay. Now just ignore this. Okay. Now just check your transform data. Not the transform data, basically encoded data. So data.
What about if we went to put the labels in the ranking form, like less pain, moderate pain, severe pain? So
Actually, this
are we
will
going
be
to use?
comes in ordinal data. Actually, we don't have any ordinal data. That's why we are putting in label encoding. We are just
No,
labeling the data.
I mean just in case we have ordinary data, are we going to use exactly the same level encoding and one hot encoding, or is there any difference
No,
tools
there is no
applied
any difference.
for ranking? Okay.
No, not any difference. Okay, all are the same.
Yes, sir. Okay.
Now, what we have to do is we have to define the feature and the target column. Okay, splitting the data into X and Y. split the data into X and Y, means the target and the input feature.
Input feature, input or feature.
What all are same, okay? You can write target column, you can take output column, you can say input features, okay? Now how will you define this? Now X is equals to data dot, tell me, drop
Drop
and columns
space,
is no, columns is equals to
space.
species, yeah, right. And similarly this is your output, okay? Then Y is equals to data and just
Space.
define species. Okay, so in this way you can define the species. And this is your what? This is your input data.
Output. Oh, that's input. That's
No,
right.
this is input.
Oh, yeah, that's right.
Okay, okay. No, 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 no. Actually, this is your output. Sorry, you are right. You are saying right. Output.
Oh, that's right.
This is your input. Why? Because if we drop the output column, so remaining will comes under in input column, and Y is your target column. Okay, so actually we are defining what? Species column as a target column. Okay. Say yes or no.
Yeah, that's right.
Yeah. Just run this. Perfect. Now split the data into training and testing part, right?
Mm.
So first we have to import sorry, from sklearn dot model selection.
Ice learner, ice skiller spelling.
Yes, sk import train underscore test split as split. I'm taking split. Okay, just run this. So x underscore train comma x underscore test comma y underscore train comma y underscore test is equals to split x and y, and then what? Tell me.
You mean the percent?
What we have to define?
Is it the percent, like 80%?
Yeah. The
80%.
test size or the train size. Okay. So I'm just taking test underscore size. So you can take test size, or instead of either you can take test size or train size. Okay. So if you are taking test size, so no need to define separately the train size. Okay. So test size is your 0.2, means 20% is your test size. Okay. Now random underscore state is equals to 42. Clear?
Yeah.
Okay. Now just check the shape of the data. X train dot shape comma x test dot shape. Let's run this. See, 266 and 67. Clear? So this is your 80% training data set, and this is your 67 is your 20% of the whole data set. Okay? Clear? Now we have to scale the data set. We have to normalize our data. Right or not?
Yeah.
Standardize the input features. So let's say SC. SC stands for standard scalar. We have to uh, put the standard scalar. So standard scalar is your, what is the spelling? LER, I think. Yeah. So this is your object for the standard scalar. Now train the just transform the data set. So xtrain. So standard scalar will only apply for the input feature. Okay, just remember one thing. Xtrain is equals to sc dot fit transform, fit underscore transform, put the parenthesis x underscore train. Similarly for x test is equals to sc dot fit underscore transform and pass x test. Okay, now just run this. Now see, check the data set x underscore train. I want first 5 rows. See, this is your transform data set. So how beautifully it has transformed. Now we have to make the model. Is this the next step? Everything is done? Tell me.
But you're gonna share this file, right? I think.
Can you do the rest of this?
I think so. Yeah, we did a couple of times before.
Yes, I think you have to, at least you have to try.
Exactly. So,
Okay.
so the model gonna be random forest model, right?
Yes,
You-
random forest. Random forest classifier.
Go ahead and then give us assignment. And then one question, we don't have to worry about outliers. You guys remember last time when we tried to find outliers and remove
Yeah.
outliers?
Yes, actually that data was not the clean data. Actually, this is the clean data. Why? Because we have imported from the
From the,
Seaborn library. Okay.
okay, got it.
So mostly the data set inside the Seaborn library, that they are the clean. These are the clean data. Okay.
Got it. Thank you.
Okay. So I'm just sharing this file to you. Please try to complete that. Otherwise, for tomorrow, we will exactly do the remaining parts. Okay.
Okay.
So we just have to check the accuracy and what
Yes,
else?
yes. Right after applying the model, you just have to check the accuracy. Okay.
Did you share the file?
Yes, yes. I'm sharing. Okay. What I have done here. Okay, just take this file. And just hold on, I'm just sharing the class notes also, okay? Everyone got the file?
Yes. Thank you so much.
Thank you. Thank you, sir.
Okay, thank you so much for today's class, and tomorrow we will meet. Okay,
All right.
tomorrow we
Good
will
night.
meet at the same time. Yeah, bye bye.
Bye. Thank you.